17 inequalities. And so inequalities, you should kind of have a gist of what that is, but that's where we got our less than, greater than, less than equal to, greater than equal to, number lines, set notation, interval notation. It's set up like a regular linear equation. However, you do have to show your answer through number line, which is graph notation, and then interval notation. So it's kind of like two extra parts, okay? Now, also, because this is not just linear, I'm going to go into all of your inequalities, which is going to be your quadratics, your rationals, and so it looks a little lengthy. I'm just going to let you know, but we're going to touch on all types of inequalities, okay? So the first ones are going to be the basics, the linear ones. Linear, meaning one term. And so we got, 1x. 8x minus 3x plus 2 is less than 2. Open parenthesis, x plus 7, close the parenthesis. So like I said, the linear kind of set up just like an equation. We're going to solve it, get x by itself, like we would a linear equation. So we're going to combine that 8x minus 3x, which would give us 5x, bring down the plus 2, is less than, and we're going to distribute here, 2x plus 14. And then we're going to get x's on one side, whole numbers on the other. Remember, whatever you move changes signs. So that would make that a negative 2x and a negative 2 when I switch it to numbers and variables. So when I combine, that makes what? 3x is less than 12. And then I divide by 3. X is less than who? 4. So that's your inequality solved. Do y'all see that? X is less than 4. Now, on a number line, you would need to provide a number line for your answer. When you have linear, I would prefer you to stick one number smaller and one number bigger than your answer. That way I know where it is on the number line. Does that make sense? So we would put that in between 3 and 5. Now, this is the main section why when I did 1-1, when we talked about linear equations, I always told you you'll probably see me work it where my variable's on the left side. It's because of inequalities. Because you read that x is less than 4. But sometimes students have a difficulty knowing what that sign is, the inequality sign. So I always tell students, if your x is first, the sign is going to point in the direction it's supposed to be shaded. Does that make sense? If you don't know, that's less than, all right? The point of this is going to the left. Does that make sense? That's the main reason why I always put my x first. So when I say shade, you're going to shade to the left of 4 because that's where your answer exists. So we're going to shade on the number line all the way to the end of my little piece, which will be 3 and on. That will represent less than 4. Now, in some schools, they did open circle, closed circle, but in college, we do brackets versus parentheses, okay? So make a notation of that if you don't know, but you have just a less than sign. It's not less than or equal to. Less than or equal to would have the bar under it, right? If you have an equal bar, then we must use brackets. That's when you use brackets. But when you just have less than or greater than, you must use parentheses, okay? So that's something you need to know because I'm going to ask. You got to put a special symbol on the number, on the answer that you solved, which was 4. And in this case, is it going to be bracket or is it going to be parentheses? Parentheses. So you're going to have an open parenthesis towards the shade, but it must be on 4. Do y'all see that? Now, that's all I'm requiring on my number line. I need to see where 4 sits, because that's the answer. And then you're going to shade it in its appropriate direction. This time it's to the left. And you'll put the symbol, the closing symbol, on your answer, which in this case is a parenthesis. Okay? Now, interval notation matches this. It's the last way you're going to show me your answer. Interval notation always matches your graph. Okay? This is where you have infinity signs. Because if I actually had a real number line, you do know, I don't know when it's going to stop. It's going to keep going indefinitely. Both directions. Does that make sense? So if I'm shading it to the left side, meaning that if I continue to keep going all the way till I don't know when it's going to stop, I'm hitting all what type numbers? Negatives. All negatives are on the left. All positives are on the what? Right. So if I keep going to the left, that's going to represent negative infinity. Do you agree? So that's what comes first in your interval. You're going to write negative infinity. I'm going to write it about right here. Negative infinity. And we're going to go, we're reading it from left to right. So if I'm starting with negative infinity, y'all's way, I'm stopping where? At 4. And I put a closing parenthesis on 4. You also have a closing parenthesis on negative infinity. Now, for future reference, you always put a parenthesis on any infinity sign, okay? A bracket means equal. And I can't put a bracket on something I don't know when it's going to stop. Like a bracket means I definitely know this is my ending, this number is in my problem. Not with an infinity sign. You can't close it never with a bracket. You have to always close it with a parenthesis, okay? And that's what I'm looking for. All 3 of these are ways you're going to show me your answer, okay? The simple solution, x is less than 4, the number line, and interval notation. Y'all seen this before? Okay, good deal. All right. Example 2. 2 open parentheses, x plus 5, close the parentheses, plus 1 is less than or equal to 5 plus 3x. Okay? We're going to distribute. That's going to give us 2x plus 10 plus 1 is less than or equal to 5 plus 3x. Then we're going to combine 10 plus 1. So that's 2x plus 11 is less than or equal to 5 plus 3x. And then I'm going to move them. So I have 2x minus 3x is less than or equal to 5 minus 11. So 2x minus 3x is what? Negative 1x or negative x. And that's less than or equal to negative 6. Now, you got a number, negative 1 on x. So I divide by negative 1. Do you know the rule for inequalities? Very good. You got to flip that inequality sign. Very good. And the reason is because you're dividing by what? A negative. Very good. You need to know that if you don't. Anytime you divide by a negative. I'm not talking about 6. I don't care about the number on the right side being negative. It's the number that's on x. If that number is negative, because that's what's going to go to the bottom. If it's negative, you must flip your sign. So x is not less than, but greater than or equal to positive 6. Those two negatives make a positive, right? And that's our solution, okay? So next we would do our number line. And we would put 6 in between, 5 and 7. And this time we shade where? To the right. Greater, that's a greater than sign. And what symbol must I put on 6? A bracket, very good, because it has the equal bar. So you got an open bracket towards your shade on 6. Does that make sense? And that's all I'm looking for on my number line. Then underneath that, your interval notation is going to match it though. So that means when you read from left to right, this time my shade don't come first. Who comes first for my interval notation? 6. 6 comes before the shade. And then I'm going which direction? To what? To the right, which represents positive infinity. Very good. Positive infinity. If I keep walking indefinitely to the right, it's all positive numbers, bigger numbers. And so when you do your closing symbols, you got what on 6? Bracket, but what has to be on that infinity sign? A parenthesis. Very good. Yeah, I see that. Questions? No? Okay. 3. 1/3 x plus 2/5 x minus 1/2, open parenthesis, x plus 3, close the parenthesis, is greater than 1/10. Okay? I treat it like I would in my linear equations. Get rid of the fractions. So, common denominator. You got 3. You got a lot of 3, 5, 2, and 10. I would think in multiples of 10, because that's the biggest one down there. 30. 20 ain't going to work, because 3 don't go into 20. So it has to be who? 30. Does everybody see 30? 30, because 3, 5, 2, and 10 will go into 30. Okay? So we're going to multiply each term by 30, which each one of your terms has a fraction. So you do know you multiply 30 by what's on top, and then you're going to have to divide by what's on the bottom. Good. And I'm just writing all my fractions so y'all can see it. I went through and multiplied 30 by what was on top, and now I'm going to divide it by what's on the bottom. So 30 over 3 makes 10. Make sure you bring your x down. Plus 60 over 5 will make 12, and that has an x too. Minus 30 over 2. 15, I bring down my parentheses, is greater than 30 over 10. 3. Does everyone see that? And then I'm going to combine and then distribute that negative 15. So combining 10x plus 12x will make 22x minus 15x minus 45 is greater than 3. So we're going to combine 22x minus 15x is 7x minus 45 is greater than 3. Then I'm going to add 45, and that's going to make 48. Then I divide by 7. X is greater than 48 over 7. And don't do any decimals. Keep it as an improper fraction. It doesn't reduce. Always check to make sure it doesn't reduce, but it doesn't. So that's our answer. Because I'm limited on space. I'm doing my number line right here. And we got 48 over 7. Now, if you don't know the two whole numbers, you could divide it to figure out the two whole numbers. It's in between. Don't stress. You can walk it down and walk it up. That's fine with me too now. You can say 47 over 7 and 49 over 7. That's the same thing. If you don't know, that's going to be between, what, 6 and 7? And then we're shading which way? To the right. And what symbol is on 48 over 7? Parenthesis. Good. So my interval notation will start with 48 over 7 to what? Pos infinity, both in parentheses. Good. Question.
So when you're breaking the fractions down, when you find your lowest common denominator, you can just take the top and divide it by what's on the bottom, and it'll give you what's supposed to be where the top number is. Like if you say 30 divided by 3, that gives you 10. So you can just say 30 divided by 3, and that'll give you what you're supposed to.
For that one. That's right. That's why I went through and multiplied 30 times 1 times this 2, 1 and 1. But I kept my bottom numbers. You see what I'm saying? And then, yeah, I did what you just said. 30 divided by 3 is 10. Now, 30 times 2 is 60. So divide that by 5 is 12. 30 times 1 is 30, but I divide that one by 2 because that had a 2 on the bottom. And that's 15. And then 30 times 1 is 30, but that one has a 10 on the bottom, so that makes 3. Still okay? Y'all okay with the linear? Yes. Okay. Because I want to get into the other ones. Because the linear y'all have seen. Any algebra class, you should have done some linear. Now, you might didn't do the ones with fractions all the time, but these are considered just the linear ones. You got one answer, okay? The next ones are, I call them compound, okay? Because you got two signs in it, two inequality signs. And let's do -5 is less than 5 plus 2x, which is less than or equal to 11. Okay, and like I said, I call these compounds because you see you got two signs, two inequality signs. Meaning there's going to be two answers, okay? So linear are the only ones that's going to give you one answer. I think the ones we're going to do from this point forth going to have two answers, okay? Now, teachers have taught this differently. I've seen some split it into two separate inequalities. I personally just work it as it is. I work it all together because it's real easy. I work from the middle out because that's where x is. X is in the middle. So I need to get x by itself. It's just that when I start moving stuff out of the middle, I got to remind myself I got to do it to both outsides. Not just to one outside, I got to do it to both of them. Does that make sense? So if I'm going to think about a regular equation or regular inequality, if I'm going to get 2x by itself, who do I need to move? Well, x by itself. The 5. Move 5 first. So you're going to move 5 by, how does it move? Subtract. But you're going to subtract it on both outsides. So that's going to give us a negative, what, 10? Is less than 2x, is less than equal to 6. 11 minus 5 is 6. Last step. Now what are you going to do to get that 2 off of x? Divide. So you're going to divide everything by 2. Very good. So that gives me negative 5 is less than x is less than or equal to who? 3. Do y'all see that? Okay. And that's your answer solved. That's the solution. As long as x is by itself, that's your solution. Now you can, I would just prefer you to just write it like that. Now I do see some people split it, and you can. What I mean by splitting it, you can also tell me x is greater than negative 5 and x is less than or equal to 3. That's the same answer. Okay? And it looks like I flipped my sign, but I really didn't when it came to negative 5. I put x first. So when I write x first, you see the open is still towards the x. You follow me? So I didn't really flip it, I turned it around. Okay? I didn't flip the meaning, I just really turned it in your eyesight so it looks like I flipped it. Okay? Now, when you do your number line, you do have to do number line and sit in interval notation. Since you have 2 answers this time, don't give me a whole bunch of extra numbers on the number line. Just put your 2 answers, okay? And you put them on there numerically. So you would put them on there where they would go in order. Meaning, negative 5 would obviously come before what? 3. Does that make sense? Now, when we do shade, because this is compound, I want you to show me where my answer would be at the same time. All right? Now, what I'm saying that is you got 2 different signs here. Okay? You have x is greater than negative 5. Now, if it had its own number line, you don't have to write this. If there was a number line with just negative 5 on it, you would shade it going to the right. Do y'all agree? That shade would be going towards the right. Okay? If you had a number line with just 3, so I could do x is less than 3, that shade would start at 3 and go which way? To the left. So where would both lines be at the same time? Between them, in the middle. Do you agree? This is where you at the same time. Does that make sense? So that's going to be your shade for all these compounds, because that's why they call compound. They're going to be happening at the same time in between them. Does that make sense? So when you do your shade, that's all I want to see. I just want to see the shade in between negative 5 and 3. Very simple now. This is how it's going to work on all the ones that's compound. I got 2 inequality signs in the problem. Now, what you got to be mindful of is that I don't have to match my closing symbols. If you notice, one of them got an equal bar and one of them don't. So make sure you're mindful of who's got to have the bracket versus who has the parenthesis. So when I look at negative 5, it's going to have what? A parenthesis. Okay? 3 has the what? Has the bracket. Does that make sense? And that's it for the number line. That's it. You showing me where it shades and you got the symbols. Now your notation matches it. Now your notation shows where your shade is. That's what your notation does. Your interval. So if I'm going to do my notation, would I have infinity signs on this one? No. It ain't. I'm not going left or right indefinitely because it's compound. I'm showing that they in between the 2 numbers. So your interval really just looks like that, what you see. It's going to parenthesis, -5, 3 with a what? Bracket. Do y'all see that? I really think compounds are kind of easy and not bad, because your shade, you already know what the shade gonna be. Does that make sense? Let's do another one. Ten is less than or equal to 2x plus 4, which is less than or equal to 16. What are we going to do first? Subtract 4, and make sure you do it to both sides. Good. That's going to give 6 less than or equal to 2x less than or equal to 12. And then what we do? Divided by 2. So we got 3 is less than or equal to x, which is less than or equal to 6. Pretty simple. Number line 3 before 6. And our shade is where? Where? In the middle. And what's my symbols? Brackets on both? Good. So my notation interval would be what? Very good. 3, 6, both in brackets. Pretty simple. Mm-hmm. Mm-hmm. Okay. Last one of the compounds. Let's do -4 is less than or equal to x plus 1 over 2 is less than 5. What we got? What we going to do first? Very good. Multiply by 2. Got a fraction, ain't got but one denominator, so you're going to multiply by 2. Awesome. So that's going to give us -8, less than or equal to x plus 1, which is less than 10. And then what we do? Very good. Subtract 1. Make sure you do it to both sides. So that's going to give -9 less than or equal to x, which is less than +9. Number line, we got -9 before 9. Shade is in the middle. What symbol is on -9? And what's on +9? Parenthesis, good. So my interval is going to be good. Do y'all see that? Not bad at all, right? No. Questions? All right. Now, that's it with compound. The next one are the quadratic. Okay? Quadratic inequalities. Okay, this is still quadratic, you know, it's squared, meaning 2 We have two answers, all right? So if we were to have x squared minus x minus 6 is greater than 0. Okay? Now, this is a trinomial. Okay, that's why it's quadratic. It's in quadratic form. And so, obviously, I'm going to have to factor. So I want to make sure you understand factoring does not go away. It's all on this test. Okay? So we're going to have to factor to get the two answers. So that's the very first thing we're going to do. So, easy factor. We're subtracting to get that understood -1. I don't have anything in the front but 1. So I'm going to stick x and x at the front. And what two numbers from 6 are we going to use? That's going to give you 1, 2, and 3. Good. And since you're subtracting, you got 3x and 2x. Which one going to have to be the negative? The 3. Good. 2 is positive. And like I've said earlier, it is very important you check what signs you throw in them parentheses, because if not, you're going to be wrong. You're going to give me the wrong two answers. Okay? It's a difference in positive 2 and negative 2. It's a difference in having $2 and owing somebody $2. That's a difference. Okay? Now, once you have factored, now we're going to set each parenthesis to the inequality. Okay? Same kind of setup, we would set it to 0. That's what that means. So we got x plus 2 is less than 3. Greater than 0, excuse me. And then x minus 3 is greater than 0. So that means x is greater than -2 and x is greater than positive 3. Now, number line. You're going to put these two. Don't put a lot of extra numbers due to the fact you got two answers. So we will put -2, then positive 3. Now, look at your inequalities, okay? You have on the first one, and I'm explaining like I did with the compound, so you don't have to write this. You got x is greater than -2. If he was on his own number line, you're going to start at -2 and take it to the what? To the right. And if you read the second one, x is greater than 3, meaning you're going to start at 3 and also take it what? To the right. Now in algebra, this is a problem, okay? It's not a problem for you to go opposite directions but meet in the middle. Y'all follow what I'm saying with this? Because that's showing that I am happening at the same time in a location. That's why we got compounds. This technically is not accurate because you got two different starts. And when you're dealing with quadratics, your number line comes in different phases, meaning my answer can either be in the middle, that would represent they're both happening in the middle at the same time, or your answer is on the outside, meaning they never have any meeting place. They're going in opposite directions. Does that make sense what I'm saying? So here, you're not showing that they're meeting together in the middle. You're showing that one starts and keeps going, and then one starts a little later and keeps going. That's kind of a that's not mathematically correct, okay? So I got an issue. Now, how I figure out where my problem is I got to figure out where my answer really is. The number line is really a false lead because my signs are pointing in the same direction, and I don't know, is it in the middle or is it on the outside? It can't be in both places, okay? So this is technically, they teach it in the textbook to test your number line. Testing your number line meaning you take a number, any random number, you plug it in to see if it's true or false to this problem. So what I like to use is 0 because that's an easy, quick plug-in, okay? 0 would represent what piece of this number line? Where would 0 be on this number line? In the middle. Do y'all agree? 0 would be in the middle. So if I went to plug 0 in, I'm testing to see if the middle is really part of my answer. Is it true there or is it false? If you go back up to the original and you check 0, that means everywhere there's an X, you're going to plug in 0, which really just leaves you with -6. Is that a true statement or a false statement? Is -6 greater than 0? No, that's false. So that means my answer can't be in the middle because that's going to give me false answers. Do you see where I'm going with this? It's not, you might get a number there, you could play with a number there, but it's not going to come up true. It's not going to make sense. Does that make sense what I'm saying? So my answer must be true on the outside. So if you would like 4, I don't go too high, just try a number. On the outside, 4 is bigger than 3. If you go and you check 4 squared -4 -6, all I'm doing is plugging back to the original, okay? That would give me 16 -4 is what, 12? -6 is 6 greater than 0? Yes, that's true. So my answer is on the outside. Y'all know that's what you got to figure out. I can solve this. I'm solving it just to get, I factor it and set it to 0 just to get the 2 answers. But I got to figure out where it really is on the number line because my inequalities are not going to tell me the truth. They're not telling me where it really is shaded. And that's the problem with quadratics, okay? You can't rely on that sign and where it's pointing. You're going to have to actually figure out true or false on the number line to figure out where it is. So it's actually on the outside because that's what came up true. Do y'all see where I'm going with this? Now I'm going to give you another ooh wow moment. Outsides work together, okay? Meaning, if it's true on the right outside, it's highly possible it's true on the left outside. And you probably said, that one, this part ain't even in the inequality. I know. But I bet if you plugged in a number over there, it would be true too. Okay? They work together. There are some incidences where they don't work together. But we're not going to get into them. I'm showing y'all the basic. So the ones you're going to be dealing with, if it's true on one outside, it's true on the other outside. Okay? But you do know in math, we can make up some stuff to make stuff not work. Okay? That's the fun part of it. So if you were to try -3, ain't that on the other side? If we plugged in -3, which would be -3 squared minus a -3, you just got to watch these signs, -6, would that give us greater than 0? That's 9. That becomes a +3, right? Ain't that 12? What's 12 minus 6? And isn't that bigger than 0? You got the exact same thing. Do y'all follow me? So it's also true over here. Okay? So your graph shows you where your real answers are. Okay? Not where the thing was pointing. Okay? So my graph shows that my answer is on the left side of -2 and my answer is on the right side of 3. It's not in between them. Okay? This is an outside shade. So when you do your notation, you got to symbolize that. Now, what symbol? Because this only has what? Parentheses? So you're going to do open parentheses at both numbers toward the shades. Okay? Now, I'm going to erase this check over here so I have some room. Now, when I write my interval notation. We start from the left side. And so that's going to represent who? Negative infinity. And we coming all the way to who? Negative 2. Go ahead and close him off with a parenthesis. And we know we got a parenthesis on the negative infinity, right? Now we skipping. You skipping over negative 2, negative what? 1, 0, 1, 2. You skipping the middle. Does that make sense what I'm saying? There's a hole in your graph. So you need to symbolize that skip is what we call a union. A union is symbolized with the U. Okay? I always tell students I use the U when I want to unite two separate pieces. You got the left piece, you got the right piece. I need to unite them with that U. You follow me? So now I've skipped over that middle. I start back up at where? 3, and I take it to what? Positive infinity. Very good. And both of them also in parentheses. Does everyone see that? That's how you write an interval notation for an outside shade. And when I say outside shade, meaning you skip in the middle. The middle is not part of your answer. Does that make sense? That's what that union is there for. It's bringing the two pieces together. Does that make sense? Have y'all seen that before? Maybe, maybe not. Questions? I know it's a lot. Let's look at another one. Number 2. X squared minus 7x plus 10 is less than 0. So very first step, we got to do what? Factor it. We got to factor it. So we are adding to get negative 7. That's going to give us, X is in the front. Bless you. What two numbers from 10 going to add and give you 7? 5 and 2. And if we add in and 7 is negative, then both of them negative. Good. Both of them negative. So now we take each parenthesis and we're going to set our inequality to 0. And that's going to give us X is less than 5. X is less than what, 2? And do you notice your signs are pointing in the same direction? That lets you know you got a problem. You follow me? So disregard what they say. When you come to quadratics, just disregard what them symbols, the inequality signs are pointing. We got 2 before 5. And really, I just do one real check. You know, on these, I can kind of tell when it's one of those special situations. And I'm like I said, well, y'all are not going to be dealing with those. But if I check 0, where would 0 be? Now, it's not going to always be in the middle. Where would 0 be on this number line? Before 2, which would be outside. Do you see? That's what you're looking at. Okay, now I'm checking outside. Last time I had 0 was in the middle. I don't want y'all to always think 0s, and you got to make sure you're looking at your number line. 0 this time will be on the outside. Does that make sense? So if I go plug 0 in, that's technically just 10, right? Doesn't it cancel out the two first terms? Is 10 less than 0? No, that's false. So it must be true where? In the middle. Your truth must be here in the middle. Does that make sense? No. If you wanted to test, if you plugged in 3, wouldn't 3 be in between 2 and 5? And I'm just showing this if you wanted to test it. That's going to be 9 minus 21. What's 9 minus 21? Negative 12 plus 10 is a negative who? Isn't that less than 0? It's true. Do y'all see that? Okay. So what's my symbols? What's going on 2 and 5? Parentheses. Good. So this time your interval is going to be just 2, 5 in what? Parentheses. Do y'all see that? Now, when I was in high school, we had something called and or and type problems. It's been not that long ago, but it's been a long time ago. We don't normally call them and or anymore. But depending on, and this will work for y'all's problems, because there's a way you can tell when you're having that special case, them special situations, okay? And you're not going to have those. But on our basic quadratics, a lot of times if you look at the original problem and look at the sign that's given, that will kind of give you an indication on how you're supposed to shape, okay? Meaning, the first problem we worked, it was a greater than. Ain't that the greater than symbol? Greater than normally is an outside shade. Okay? Greater than is normally outside. The second one we worked was a what? It was a less than. And less than is normally in the what? Middle. Okay? Let that sink in. When we did compounds, all of them were what? Less thans. Do you see the pattern? And all your shade, because I told you compounds are going to do what? Shade in the middle. Always, because they compound. You're not going to get a compound that's got greater than symbols on it. You follow what? Let that sink, because greater than going to go which way? Out. You go on the outside, okay? That's a pattern that works, okay? Now, it ain't 100% guaranteed, because there is some situations. However, the ones you're going to work with, this will work. I have told this to students, and literally, they don't even think about checking. They look directly at this sign and be like, okay, that's going to be in the middle, or okay, that's going to be on the outside. You follow me? Because less than normally is going to show the compoundish, they're going to be meeting in the same place. Okay? Less than, that's the normal pattern of a less than. It's going to be in the middle. Greater than, and this doesn't matter if it's got the equal on it or not, okay? You know, the equal just means bracket versus parenthesis. Doesn't have any bearing on the shade. So it goes for that too. But greater than is going to normally be an outside shade. Okay? So kind of keep that in mind with the next examples and when we get into 1-8, because that still needs to be in play. Does that make sense? That will help on this whole testing tremendously. And I promise you that will work on your test. And my labs. Okay? Questions? I am right at time, so this will be a part 2 to this.